In this video, we are going to look at some problems based on refraction. A light ray travels from a medium of refractive index n1 to a medium of refractive index n2, where n2 is less than n1. So let's just write that down. What does that mean? If n2 is less than n1, that means n2 is the rarer medium and n1 is the denser medium. So if I label it on the diagram, you can see that the denser medium is on the top and rarer medium is at the bottom. Ray is traveling from a denser to a rarer medium, and that's why it should bend away from the normal, which means 3 is the ray which represents the refracted ray. Next question, what happens to the green light when it passes from air into a new material? So it's passing from air into a new material with a refractive index of 1.5. So we know that refractive index is defined by this equation C over V, where C is the speed of light in vacuum and V is the speed of light in the medium. Okay, in this case, the medium is the new material. That's what they said, it's a new material. So vacuum, you can also assume that as an air, that's the closest which comes to vacuum. It's asking you what will happen to the speed of light. So it's traveling from air to the medium, and we know that the refractive index is given as 1.5. That means the light is going to travel slower. Obviously, it's moving from a rarer to a denser medium. But how much slower? It will become 1.5 times slower than the speed of light in vacuum. So I can write the speed of light in the medium will be C over 1.5. That means the speed of light divided by 1.5. Speed of light in vacuum divided by 1.5. That will be the speed of light in the medium. So obviously it means that the speed of light in the medium will decrease by a factor of 1.5. The next question, a ray of light travels from air into an unknown medium as shown below. Angle theta 1 is given to us as 60 degree in air. Theta 2 is given as 40 degree in the unknown medium. So if you look at the diagram carefully, the ray is traveling from air to the unknown medium. Let's name the mediums as medium 1 and medium 2. Snell's law gives us n1 sine theta 1 equal n2 sine theta 2. n1 is air, that means n1 is equal to 1. The first medium is air, so n1 is equal to 1. So we can substitute the numbers into the equation and we can solve it using our calculator, shift solve, and get the answer as 1.35. What happens to the speed of light as it passes from air into the unknown medium? So let's write down the refractive index of each one. n1 is 1, n2 is 1.35. So light is going to travel from a rarer to a denser medium. The speed of light will decrease as it enters the denser medium, and it will decrease by a factor of 1.35. A ray of light in air enters a glass block at A and reaches surface B, where it just skims the surface. Let's understand what's the meaning of skimming the surface. If you look at the diagram, here the ray of light is along the boundary of air and glass. That means it is skimming the surface. What is the angle of incidence theta I at the interface A? So let's name the mediums. Air is medium 1, glass is medium 2. Snell's law, n1 sine theta 1 equal n2 sine theta 2. We substitute n1 as 1 because air is having a refractive index of 1. Sine theta 1, we don't know what is theta 1. n2, which is glass, it is given refractive index is 1.4 times sine theta 2. But we are stuck because we don't know what's the value of theta 2. So let's label it on the diagram so we can see where is theta 2 in the diagram. Now if you watch carefully or look at the diagram carefully, we can see that we are having a right angle triangle here, where the angle which the ray inside the glass makes with the normal is theta, And so in this triangle you have got theta 2, theta and 90 degree. So we want to find what is theta 2 so that we can find what is theta 1 from the Snell's law. But for that, first we have to get what is theta. Now angle theta, which is inside the glass block, is the critical angle, because you can see that the refracted ray is skimming the surface. So angle of refraction, you can see that it is 90. So we can use the Snell's law once again. N for the glass times sine theta equal N for air times sine 90. So remember that this equation we wrote is for this part of the diagram. So here this theta is the critical angle and this 90 degrees is the angle of refraction. Okay, so we are using the Snell's law for the second time, for the second refraction which is going to happen. Okay, now we substitute the numbers. N for glass is given as 1.4 times sine theta equal N for air is 1 and sine 90 is also 1. We can use this to get the value for theta, which is 45.6. Now that we have the value for theta, focus on the triangle. Using math concept, that's the angle sum property of a triangle. That means if we add the angles of a triangle, it should come out to be 180. We have theta as 45.6. So using that, we can get what is theta 2, which is 44.4. Putting it back into our equation and getting the value of theta 1. So theta 1, you can use shift solve directly on the